Hello everyone, today we'll be working on LeetCode 108, convert sorted array to binary search tree. So we are given an integer array called nums, and the elements are sorted in ascending order. And our goal is to convert this array into a height balanced binary search tree. So to better understand what they mean by height balanced, let's look at a diagram. Alright, so this is an example of a binary search tree that is unbalanced in its height. So according to the prompt, the balanced tree can only have a one layer difference in height, and we have a height difference of 2. So the left node of 37 and the right node of 82 both stop at the third layer, while the deepest branches go down 2 more layers. So we have layer 1, layer 2, 3, 4, and 5. Alright. So let's look at a height balanced. Alright, so we can see here that there's only a one layer difference between the nodes that are stopping here and the nodes down here. And that's exactly what they want us to do with this sorted array that they're giving us, is to turn it into this tree. Alright, so let's talk about that. So if we tried inserting the nodes from either start or end of the array, we'll get a binary search tree that is either all left nodes, that is going down this way, or all right nodes, because these are already sorted. So we can take the sorted nature of the array and use that to our advantage. So we will use the middle index. In this case, this is going to be 61, and that will be our root node. And then from there, we will look at the numbers to the left of 61 and get the middle from there, which would be 37. And then we repeat this process. All right, look at the numbers to the left of 37, get the middle, and we have 22. Alright, so I'm going to scroll over here. So this is what our algorithm is going to be doing. Is we're going to get our initial root, and then we're going to look to the left of it. So start and end, and then 61 is the node that is, we're inserting a node into its left. So 37 would become the left node of 61. Then we look to the right of that, or excuse me, to the left of that. 22 becomes the left node of 37, and then 12 becomes the left node of 22. We don't have any more nodes, so we go back up to 22 and then get the right for it, which is 34. Now we're back up to 37, and we're looking at 45 and 52. So 52 becomes the right, and then 45 becomes the left of 52. Back all the way up to 61, and you can see how this process continues all the way to the end, which will get us this tree that looks exactly like that. So let's go ahead and type out this code and see what that looks like. So the first thing that we need to do is we just need to create a helper function. So I'm going to say function, and I'm going to name it convert. And this is going to take a start and an end. So these are going to be integers that will point to the different indexes of our nums array. So if the start is greater than the end, then we're going to return null. Alright, so if it's not null, then let's figure out what the middle index will be. So we're going to take math.ceil, and we're going to add the start and the end indexes together and divide them by 2. Next up, const root. Alright, so this is going to be the root for that particular level for those elements. So that's going to be a new tree node. And we're going to give it a value of whatever the middle index is. Alright, so then root.left is going to be convert, and we're going to take the start and then we're going to take the middle index and subtract 1 from it. All right, so when we initially get 61, for example, we're just going to keep the same start, but then move the end 1 to the left of it. And now for the right side, root.right, we're also going to convert, and we're going to say mid plus 1, so the middle index, we're going to move it 1 over to the right, and then we're going to go all the way to the end. And lastly, we just need to return the root. And then outside of our helper, we're going to call convert. And we're going to start at the beginning of the array and then the end of the entire array. And that's all there is to it with this. So let's go ahead and submit that. All right, very good. I don't know why it took so long, but yeah, so that's pretty good results right there. I hope this was helpful for you. If you have any suggestions on things that you would like to see, please leave a comment below. Other than that, I hope you all have a great day.